All right, this is lesson 2.8, and we are going to be reviewing all the operations with monomials, okay? So let's just review the rules here. Anything to the 0 power is 1, right? That's a 0 exponent. Negative exponents have to be rewritten so that you then make a fraction, like I would move this down to the denominator, change that exponent to a positive value, okay? When we use the product rule, we add exponents. So that would mean once we have the base x to the a times x to the b, that gives me x to the a plus b. I know it's weird because we're using letters, but when we use numbers, we just add the numbers together. The quotient rule says we subtract exponents. So here we have x to the a divided by x to the b. That would be x to the a minus b. Then the power rule says we multiply exponents. Right? So when I raise a power to a power, that gives me x to the a times b. Just a little review. All right. The most important thing to think about when you are considering adding or subtracting monomials is you need to combine like terms. You can only add or subtract monomials that have the same variable and the same exponent. Then you want to keep the variables and exponents the same. And then you add or subtract the coefficient. Remember, that's the number in front of the variables. If there is no number in front, put a 1 there. All right, we'll do some examples, but you can only add or subtract things that look alike. We have more examples on this paper. Don't worry, we will. We're not going to divide up into groups. We're going to do this with each other. All right, so this one's kind of like you got to think backwards, okay? So I'm multiplying, so that meant I added the exponent. So if I subtract from here, that gives me 10. Okay? If I'm dividing, that means I subtract the exponent. So if I subtract the exponent, something minus 5 gave me negative 7. So that would be negative 2. Oh, so we just do the opposite, right? If I subtract, that means I would add 5. I'm sorry, I don't know why I would do that. All right, so you just do the opposite to solve for what's missing, right? So if you're multiplying, you're adding, so the opposite of adding is subtracting. If you're dividing or subtracting, the opposite would be to add. That's kind of weird. Here we are multiplying because it's power to a power, so we're going to divide 15 by 5 and get 3. Okay, here's a case of adding like terms here, right? There's a 1 here. And 3 plus 1 gives us 4, right? You see that they have the same variable and the same exponent. So that also has to stay the same. All right, now let's look at some examples. This is just adding and subtracting. So combine like terms. All right. So for number 5, I'm just adding, see, notice they both have w to the second power, w to the second power. That makes them like terms. You just add the numbers, 6 plus 11, 17, w to the second power. For number 6, always check to make sure you have the same variables and the same exponents on both sides. Negative 2 minus 8 is negative 10. Again, I have RS, same thing. Remember, minus a negative becomes a big, fat, giant plus sign. Negative 5 plus 5 is 0. Do not write the RS. I mean, you could, but a waste of ink. Okay, here we go. So now I have two different things here. Okay, these are the like terms. They both have AB. Negative 5 plus 19 is 14AB. Then I have this negative 6b and negative 1b. Put a 1 there, because if you don't, then you might forget to count it. Negative 6 minus 1 is negative 7b. That is how you do that, okay? Like terms, my darlings. Number 9, same thing. Okay, I start with this x squared. I'm looking for another x squared. Hey, there's one. 4 plus 5 gives me 9x squared. Then I have an x term and another x term. There's a 1 here. Negative 3 minus 1 is negative 4x. Then I have this negative 27. Like so. Fabulous. Fabulous. All right, last one here, number 10. We have mn. I have another term with mn. So 15 minus 28 gives me negative 13 mn. Then I have an m squared term and another m squared term here. There is a negative 1 here. Negative 1 plus 3 is positive 2m squared. And then I have this n squared. I don't have any other n squared, so you're just going to write it down. If you were going to put this in standard form, you'd want to put your highest degree exponent, but I'm not too worried about that. That's totally fine. Just as long as your signs are right. All right, so now we got words. Subtract 8rs from negative 3rs. Well, if I write that down, negative 3rs minus 8rs. That is me subtracting 8rs from negative 3rs, which gives me negative 11rs. Fabuloso. Find the sum. That means I'm going to add the two together. So 2p to the 5th, q to the 7th, plus negative 16p to the 5th, q to the 7th. We just have 2 minus 16, or 2 plus negative 16. That's the same thing. That's going to give you negative 14 q to the 5th, q to the 7th. All right, that is adding and subtracting monomials. We don't do anything with the exponents. We don't do anything with the variables. They stay the same. Now we're going to multiply and divide. Okay, multiply says we add the exponents. This gives me x to the 12th because we add the little numbers together. We're adding these together. W to the negative 7. Remember, I need positive exponents, so I need to rewrite this. 1 over w to the positive 7. When you have coefficients, you actually need to multiply those together because we are multiplying. So it is like 7 times 3. 7 times 3 is 21. Then I add my exponents. So 4 plus 9 is 13. Okay, when they get larger, please take your time and slow down. Okay, we multiply the coefficients together. 6 times negative 2 is negative 12. Then I take my a's and I add my exponents. I have negative 2 plus 11 gives me a to the 9th power. Now I have my b's. Negative 1 plus negative 4 is b to the negative 5. All right? Everything's cool here except for that b has a negative exponent, so I need to rewrite this whole thing. My positive exponents, right, there's a positive 1 here for that 12. All my positive exponents stay in the numerator. But my negative exponent comes down below, and then I can change it to a positive. All right, that's multiplying. Remember, dividing, we subtract the exponents. So this is 6 to the 12 minus 14. That gives us 6 to the negative 2nd. We have to rewrite this. 1 over 6 to the 2nd. All right, number 18, if we're subtracting 7 minus 4, that gives me m to the 3rd. 16 minus 2, that gives me n to the 14th. When you have coefficients, the same thing happens when we're multiplying. We're going to do the operation. So 45 divided by 5 is 9. P to the 3 minus negative 1. Be real careful if you have a negative exponent because minus and negative changes to addition. And now I have 9 c to the fourth power. In number 20, I'm dividing 20 by negative 10. That gives me negative 2. Then I have a to the negative second minus negative 10. Again, changes to addition. That gives me negative 2, a to the 8th power. Oh, here we go. When you go to divide 16 by 12, you're going to get a fraction. I mean a decimal. So just keep it in fraction form. So you want to reduce 16 over 12. Well, 16 over 12 reduces to 4/3. Then I'm just going to keep all my exponents on the top for now, and then I'll figure them out when I get down there. Okay, so c to the negative 5, or negative 6 minus negative 5, and d to the negative 2 minus 2. Well, we'll see, negative 6 plus 5 gives me negative 1. I wrote C on the bottom, and I don't know why. I guess I knew it was going to. Negative 6 plus 5 is negative 1. That's going to come down here and have a positive 1 now. And negative 2 minus 2 is negative 4, so that's also going to come down and have a positive 4. That one's a little complicated. I'm not going to lie. All right, powers of monomials, 20 to 27. I was just kidding, 22, 27. All right, powers say we multiply the exponents, multiply the little numbers. That gives me 3 to the 20th power. Multiply these. K to the 24th power. Multiply those. W to the negative 18th. But then we need to make sure we have positive exponents. So 1 over W to the 18th power. If you have a coefficient, you must make sure you raise that to the power. So this is 9 to the second power times W to the 14th, because you multiply the little numbers together, but you raise that coefficient. This is the coefficient. We raise that to the power. 9 to the second power is 81. And now 81 W to the 14th. All right. I need to raise this negative 2. Please use parentheses when you're dealing with negatives, okay? We're raising negative 2 to the 5th power, and then we're multiplying these little numbers. So A to the 15th, B to the 20th. When I plug in my fancy little calculator, negative 2 to the 5th power, that gives me 32. I already figured out how many A's I have and how many B's. All right, this is one of those freaky ones. I don't know if you remember from Friday, but if you have a negative exponent, you want to be really careful about that, okay? So I'm going to keep this 4 like this, raise it to a negative 2. Then I'm multiplying these. So R to the negative 6 and S to the positive 3. Because a negative times a negative is positive. So who's going down below? Well, the 4 to the 3rd power is, and the R to the 6th. But the S is staying on top. So I can erase that one. And I can write this S into the 3rd. Right, that goes up here. Now 4 to the 3rd, you can figure out in your calculator, because if you do have, you can finish this all the way out. So it's 64 R to the 6th power. That is what your answer should look like. All right, so now at the bottom of your worksheet, 28 to 36, there is some mixed practice. What I would like you to do is pause the video, and then when you're ready, when you have all your answers ready, come back and check your answers, okay? Okay, well, hopefully, check your work, see how you did. I hope you did well. If you have any questions, please do not hesitate to send me a message on Schoology. I do my very best to respond in minutes if I can. And I'll see you guys tomorrow. Remember, you have a quiz tomorrow on this, so good luck studying. Bye.